All right, like I just said, thank you all for coming, everyone. We're gonna get started about now. Turn my camera. Okay, there we go. So hopefully everyone can see my screen. I'm pretty sure that you guys can, but in any case, welcome again to another one of our Elite Pathway Symposiums. This time, we'll be talking about specifically machine learning and how to analyze air pollution's impact on lung cancer using machine learning. And this presentation will be presented by Carol. And Carol had earned the MIT's Math Prize for girls. She was also a four-time Amy qualifier, and she has multiple national and state math awards. Um, and all in all, she's very impressive. So, without further ado, I'll go ahead and quickly explain the structure of our presentation here. But it'll be pretty simple, right? First of all, we had our introduction, which is just about to be finished. Second, we have the presentation, and then third, we'll have the dedicated Q&A session after the presentation. However, if you guys have any questions, just go ahead and type it in the chat. We'll either answer it on the spot or we'll wait until the end to do so. But in any case, it's better that you get the question out than just hold it until the end, just in case you forget. But yeah, there's not really much else to cover here. But otherwise, be courteous. And yeah, I think that you're able to share your screen, Carol. So go ahead.
Okay, let me just share my screen real quick. Get the slides. Okay. So I'll be talking to you guys about my research. And so this summer, I decided to do some research about pollution. So I'll just be going through all the steps of this research, what I did, the whole process of it. So in the beginning, I just prepared, and so I first chose a topic, obviously, and the way I went about doing this was I just searched for what I was interested in. At first, it was just learning about science in general because I wanted to narrow it down, but I didn't know enough about anything. And so I just watched a bunch of educational YouTube videos, like from Kurzgesagt or Veritasium, however you pronounce it. And then I looked at Google, Kaggle, sorry, which was this database sort of thing where people share their code and also share data sets about various topics. So I just went on there, searched for things that were interesting, and hopefully find a data set that I could analyze using machine learning. And, um, I did have some ideas, but it didn't quite work out. I explored renewable energy, and I learned a lot about random stuff like pumped hydro storage, geothermal energy, solar energy, their storage problems, stuff like that. I also learned about wildfires, um, but these ended up becoming much more engineering problems rather than research problems where I could use data sets to analyze um things. And the things I did do to prepare for this research was I learned machine learning from a course by Andrew NG, and he's this like awesome guy who gives out machine learning courses for free, or I just pirated it. I'm not sure. I just found it on Bilibili, but yeah, it was very helpful. It was very informative, not helpful. I watched all 140 plus videos, but I didn't use like 90% of the information, but it was interesting. I also bought a new laptop because I didn't realize how much storage I would need for this research. I downloaded like 50 gigabytes of data, and when I did the data processing, it took another, like, 100 gigabytes, um, and that was only, like, the final result. The actual processing, like, all the logs that it, remembered, that it calculated, like, that took up well over 500 gigabytes of storage, and so, yeah, this is why I needed a new laptop. About my topic is air pollution, and I follow um, 3 chemicals three types of air pollution: NO2, which is nitrogen dioxide; SO2, sulfur dioxide; PM2.5, which is like these fine particles in the air. And so I wanted to see the impact of air pollution on your health, specifically lung cancer. The sources I used was air quality data from the EPA, cancer incidence data from the National Cancer Institute, county area. I needed this for like a small portion of my research, but I'll just include it here. County data from the US Census Bureau, and weather data from UC Davis. It was just like the temperatures. The variables I used was the amount of pollution, so the minimum, maximum, and average daily pollution, the average daytime and nighttime pollution, variability, which is like how much it fluctuates daily. So that's the difference in maximum and minimum pollution, difference, sorry, in daytime and nighttime pollution, temperature, which is temperature data, maximum, minimum, average temperature daily, and lung cancer. So this is the incidence rate of lung cancer per 100,000 people. This is to keep the data consistent. Yeah, all the pollution refers to just the three types of pollution: NO2, SO2, and PM2.5. So the question is, how does air pollution affect lung cancer? And my hypothesis is that increased variability in pollution and decreased temperatures are likely to elevate the risk of lung cancer, with a particular focus on the impact of air pollution on lung cancer in the United States. This is what I wrote on my markdown file, and so I just copied and pasted it here. So let's go on to data processing. This part was honestly the most challenging part, and also the most unexpected, because I just thought I would take data off of Kaggle, a random data set, I would just find it. But then I wasn't satisfied with any of them, and they were just like kind of weird. So I just combined my own data. Like, I created my own data set from like these 4 sources I found on the internet. Um Using this program called MSSKL. It's a system that allows you to manage large amounts of data. And I think if I were to share my screen a different way, sorry. Um, so here's MSSKL, and basically, if I just go into one section here, you can see that this is a giant data set. It runs this table, and so this is the table of all of my data, and I used all of this in order to create this combined data set that you could see right here. And I uploaded this combined data set onto an RStudio. And so yeah, that's what I did for like most of the summer. It was just processing this data, and like the machine learning part wasn't that difficult, and I didn't expect that. It was actually the data processing. Um And so a big part of it is feature engineering. So that's transforming raw data into features that you can use. So a lot of the data was very messy. I didn't need all of the data. I didn't need um stuff like everything about the counties, the states' names. If you go onto the EPA site, there are like 20 different variables. But only one output, and like I think I only needed the like 2 of those variables. And so I also combined the data. So the data I got from the EPA site was in hourly, but then I had to change it to daily, and then I had to change it to monthly because it was just too much data. So these are all the steps I used. I won't be explaining it like in detail right now, but basically I took the 4 sources, I imported it, and then I cleaned it by like getting like by removing all the weird typos. I know when I imported it, some variables, some values had like quotation marks around it. I had to get rid of the quotation marks, get rid of random spaces, get rid of .coms. It was just kind of weird. And then I had to just combine all the data together and bring it to RStudio. challenges I came across along the way. So some data, there were multiple outputs for the same variables for the same features, and so I had to only choose one output because having multiple outputs is not okay. Um, in addition, there were some counties that were huge, and the sensors that detected it couldn't really detect that large amount of area and measure the air pollution correctly, so I had to get rid of the really large counties, and that was probably like the top 10%. And then I had to do, as I mentioned before, the hourly to monthly aggregation. And so, um, when I imported the data, it was hourly data. It took, I think, no, it took like 24 hours in total just to import the data and like open it. But once I changed it into monthly and really cleaned it up, it as you could see when I opened the combined file, it took like 2 seconds. So I really had to like cut down on the amount of data I had. Okay, now into the machine learning part. Um I used a program called RStudio. It's right here. This is what it looks like. Um the left side is my code. The right side is what it looks like if you were to open an HTML. So first off, I used the machine learning algorithm XGBoost. It's an optimized version of boosting, a process where it builds a series of simple decision trees. And I won't go into decision trees today, but basically, I really needed an algorithm that was fast just because I wanted it to be fast. Um, it works well with large data sets. It can handle missing data and it can determine feature importance. So my goal was to rank the features by importance to see which one was the most important. And I think I printed it out here, but on the R Markdown file, I showed how much missing data there was. Um, and so as you can see, the median max NO2, it's missing half its data. And if you were to go back to um the table, you could see that the reason why it's missing half its data is because some counties I ordered this data by county, by the way. Some counties only had one of SO2, NO2, or PM2.5. So while it might have like all of the PM2.5 values, it might not have SO2 or PM2 or NO2. And that was a huge problem. So that is why I used XGBoost. It's very good with missing values. Um, and that was, I think, the main reason why I chose XGBoost. I also did multiple imputations in Lasso. Multiple imputations is, so sorry. XGBoost is has this missing features uh method built into its program, into its algorithm, so I didn't have to do any pre-processing beforehand. Multiple imputations is what I did for Lasso. So Lasso is just like a regularization technique. Um it's a way of like getting rid of features to shrink the number of features I have. And it doesn't allow any null values, it doesn't allow any missing values, so I had to use multiple imputations in order to fill in that missing data. And you might be thinking, well, why would you fill in that much missing data? Like, isn't it wrong to fill in half your data with like fake values? But my initial approach was to get rid of all the rows that had at least one missing value, and that shrunk my rows from 100K down to 7K. So if I were to do, like, one way of just removing all missing values, I would remove 93% of my data, and I would much rather add in data than to remove basically all of my data. And so yeah, I use these two algorithms, XGBoost and Lasso, in order to do feature selection, choose the most important features. And here are the results. So the amount of pollution in lung cancer has a positive correlation. So if the pollution goes up, the lung cancer goes up, and that's quite intuitive and obvious. It's been proven. Another thing I found out was temperature in lung cancer had a negative correlation. So when the temperatures are cooler, the lung cancer increases. Um, Daily variance in lung cancer had a negative correlation, so uh should be positive. Sorry. But yeah, so if the daily variance is higher, then the lung cancer is higher. As for the feature selection, the most important factors according to XGBoost are the temperature related features. Um, and then this one was really like a really obvious one. If you were to look at the graph, you could see that median diff max min NO2 is the highest bar. So that would mean that it's the most important feature. And also the variability of all three pollutants are also important. As for loss of the most important features are the temperature related features, NO2, and the variability in NO2 doesn't seem to be important, which directly contradicts what XGBoost said or gave me. And the reason for this is that XGBoost is ideal for managing large data sets with complex non-linear relationships. That's the key part. It's non-linear. And Lasso excels in linear relationships. So depending on whether my data is non-linear or linear, it's probably non-linear. XGBoost or Lasso would be more effective. In addition, Lasso is better with simpler data sets. XGBoost is better with more complex data sets. And so I would consider my data set pretty complex. And yeah, we could explore what I have in my R Markdown file. So if you start from the top, it's just the beginning of like a research paper. I haven't finished it yet. As you can see, my abstract is totally empty. I imported a bunch of libraries. Here's my data that we talked about, all the features. These are all of the variables and their explanations. It's very complicated and hard to understand because I had to explain it using like all the words possible. But like, it's not that complicated when you just think about it intuitively. Here's my processing chart. Here were the challenges I came across and how I solved it because these might be some concerns that people might raise. And then here's when I imported the data to show people. The exploratory data analysis part is when you explore the data using visuals. Um, So the first thing I did was I explored the missing data, showed that it was indeed a problem, and that is why I needed multiple imputations um and XGBoost. Here are all the histograms of everything. I just added it to show what the distributions look like. If you're to see here at SO2, it's a very strange looking distribution, and I went to investigate why that happened. This 800 right here, the really high numbers, it's because there was a volcano in Hawaii. Um, and that just released a lot of SO2 into the air, which is what skewed the graph a lot. I didn't get rid of that data point because it's a valid data point and not like an error. We could skip all that. I did initially try to do another algorithm, two other algorithms, principal component analysis and k-means clustering, but then I quickly found out that it was quite redundant. So what these two do is it groups all of the variables into clusters to see which ones correspond to which. And what ended up with happening was all the NO2 data points, no, all the NO2 variables just clumped together, all the SO2 variables were combined together, and then all the PM2.5 variables were combined together to know the temperature, and it was just a very redundant result. Didn't show anything new. That was part of K-means. Then XGBoost, here is the graph that I showed. It's the results. Lasso, I won't be explaining what these plots mean. But oh, multiple imputations, I should have explained this. Multiple imputations, basically, um, it doesn't fill in one value per, um, it doesn't just fill in your data set. Like, it doesn't fill in the missing values for your data set. I mean, it does, but it doesn't fill it in once. It's multiple imputations because it fills it in multiple times. It gives you multiple data sets. So I said I wanted 10 data sets. So what it did was it gave me 10 data sets that had all the values filled in. So there were no missing values. And I just used all those data sets, put it into Lasso 10 times, and I got the results. Here's the feature importance. And this is just based on how many variables got removed. So median, diff, PM, AMNO2 got removed like 9 times, so it's probably not important. And yeah, that's basically my research project this summer.
All right. All right, there we go. So, I mean, first of all, that's very a lot of information to take in. I've done a little like research myself, so like I'm somewhat familiar with like the things you did, but to be honest, um, yours was much more of like a much more comprehensive project. So I'm trying to share my screen right now, but it's like not showing up. I don't know why. Okay, there we go. All right. So, like I just said, great presentation. Thank you so much for sharing. I guess the biggest thing I wanted to ask is, you know, what kind of conclusion could you have drawn from the graph or from your sorry, from your project, if anything, right? Like, what do you feel like is the best takeaway from what you did?
Like the results from the
Yeah,
research or just like from what I learned personally?
I guess both then, both research and what you learned
Okay.
personally.
So the thing that kind of surprised me, like that was kind of aiming for in this project was to
Mhm.
see how temperature and variability impacts lung cancer. And these two things I haven't really seen discussed in other places. Like I keep seeing, yeah, like as the pollution increases, lung cancer increases, and that's it. There isn't like, oh, if there's like a little bit of air pollution in the daytime and a lot at nighttime, how will that like difference affect lung cancer? And it affected people a lot, I guess, like from here. And same with temperature, if you live in a colder place, you have a higher chance of getting lung cancer. And obviously, like there are many other factors that go into lung cancer. There's like smoking, there's like your personal habits, um just like what kind of environment you live in, if you live in an urban area or a suburban area. And there are many things like that. It like it isn't just pollution that affects it, obviously, but like from the data that I have, like that is a result I got. As for the personal lessons I got, um, if you were to do something challenging like this, there are a lot of things that you'll learn, and a lot of unnecessary things that you'll learn. So for example, in the beginning, I was like, I need to know everything about machine learning. And so I took a whole course, but then I ended up using like one thing from there.
Great.
And that was just very disappointing, but also like, yeah, um, I should have expected that to happen. And also in the process of exploring like my research topics, I just learned a bunch of random information about the environment, and that just seems pretty cool to me. Like, it's not just this like research that I got from this whole experience, it's also a bunch of random knowledge that I might need in the future, just not for this project. But I would say it's like knowledge is knowledge. You just get knowledge from stuff like this, even if it's not useful in your personal goal in the moment.
Yeah, I mean that's a good takeaway. How long, like you said this went over like the entire summer, but how long did it like in hours take you to do like all of this?
Um, if so, there were some days where didn't spend any time at all, and some days where I spent a lot of time on it. So if we were to average it out to like 2 hours per day, how many days are in the summer? It's like
I don't know, like according to Phineas and
60
Ferb, there's
days,
104, but I don't know, like
104
I don't know, I don't know. I think it's more closely to like 3, 2.5 months, something like that.
months. So like 60 days plus like so 75 days or something. That's like
You could just say
150
75
hours.
days, yeah.
Yeah,
150 hours. That's
yeah.
crazy.
Say
So
that.
that's the amount of hours it takes to like do a project of this size. And this isn't even like necessarily, I don't know, how big is this like to put it in perspective? Is this one of the larger types of projects you can do, or is this relatively small?
Oh, it's a pretty large project.
Yeah, okay, that sounds about right. Yeah. So yeah, 150 hours, this kind of thing that goes into like data science, right? And it's like it's complicated. Did you have fun?
Um, yeah, sometimes. I would say most of the times, but like it's just it just feels nice having accomplished something like this,
Mhm.
and I feel like looking back, like in the process, it was kind of painful just like learning stuff that wasn't useful.
Yeah.
And I felt like I was like just dealing with this in the beginning.
Mhm.
Um but then as I got to like the actual coding part, the combining part where stuff actually looked like where it actually looked like things were happening,
Mhm.
that's when it felt good.
Okay. Yeah, I mean, I don't know if I can say all that for what I did because I didn't enjoy it that much. I thought it was incredibly tedious. But yeah, I'm glad you got some fulfillment out of that. So, does anyone else have any other questions for Carol and her presentation?
Yes. So when you mentioned the Kaggle part, I think I'm just curious, do you try the Kaggle? I think they got the orbital notes or something that like Kaggle essentially offers you a type of GPU service at that point. Do you try any GPU service on the Kaggle or no?
Um, I didn't really explore Kaggle that much. I
Yeah.
just like I just spent like
You just
10
took
minutes
data. You
on
just
that
took
site,
data.
just looked at the like data. I was like,
I'll
I
just
don't
take
really
that.
know.
That's good enough. And just took it.
Yeah, and then I just like decided not to use it.
Okay, okay. Totally get it. Cause like I think they only give you like 10 gigabytes of free storage and then the rest you need to pay for.
Ooh,
Yeah.
that's like I can't do anything with 10 gigabytes.
Yeah, I was gonna say, didn't you said you had to take 500 gigabytes just to do your project?
Yeah, and it's like okay, I need a new laptop anyways, so it
Right.
was
This
just
is a
like a
perfect
I
like
didn't I didn't
transition into
I
that.
didn't buy the
Right.
laptop just for this project. I just like
Right.
yeah.
Yeah. Great. Does anyone else have any other questions?
What was like the most interesting part of the project for you?
Um, hmm. Probably just like figuring out which algorithms I needed because I tried out like a bunch and then while I was like coding it and stuff, I did more research on all the algorithms and sometimes it was just like kind of useless and like I don't know, just learning about all that stuff, seeing what's there in data science, like that was interesting to me. And like I guess like the learning part was more bearable because I was like doing something with it and like I don't know, just taking notes on something is really boring, but when you um craft something with your knowledge, it is more interesting and it motivates you more. And so just learning about that was the most interesting part because I was doing something with it.
Hmm. It's a lot of research you had to do, and I do not envy you at all. Okay. Anyone else? All right, then in that case, I mean, there's not really much else that needs to be said. Thank you all for coming, and I hope you guys at least learned something. Thank you again to Carol for presenting. Obviously a lot of work and a lot of effort came into this project. So, yeah, I mean, it's pretty crazy. You cataloged a lot of stuff. So, hopefully this kind of gives you an idea of what a project of this sort would entail, right? Because data science is a pretty complicated field, but also it's not too complicated considering how she can do all that with only like one thing that she learned from the course. So, I mean, that's the thing. As someone who's done like a little bit of data science myself, I mean, that's pretty representative of projects like that. It's not like crazy, like it's not crazy, like exciting, but at the same time, it is just a culmination of a lot of work and a lot of knowledge. So, thank you again to everyone who came. And yeah, hope you guys have a good weekend, and we'll see you guys for the next one. Bye bye.
Thank you. Bye.
Bye.
Bye.